Please give a warm welcome to Evelio Tarazona Caceres, Engineering Manager in Instagram. The topic of the lecture is Server-Driven Cross-Platform UI Features Apps. So please, we're really ready to welcome you on the stage. Round of applause, I think. If you will need some kind of help from me, I'll be over there.
Sounds good.
Thank you.
Thank you so much for the introduction. I'm glad that you switched to English, otherwise I wouldn't be able to understand when I should come. But yeah, thank you so much for the introduction. How is everyone? Mirtrude Mobile, huh? Here we are. First offline conference since ever, it kind of feels. But yeah, this is one of the longest title talks that I've ever given, so I'll try to go a little slowly. But yes, as I mentioned, welcome to Server-Driven Cross-Platform UI Features Apps. So my name is Evelio. I'm an engineering manager at Instagram. There we go. So I work on this little app that hopefully most people are familiar with. So overall, we focus and we believe strongly that our mission is bringing people together, bringing people closer together, and as well, not only to the people that they care about, but also the things that they care about. Example, for me, it's super important to connect with my family and friends on Instagram, and as well follow topics that I care about, like soccer, traveling, etc. So we achieve this through certain mechanisms, and I believe this is working because according to public stats, these are not internal or anything like that, nearly 1 billion people use Instagram monthly basis, which is mind-boggling to me. Similarly, the percentage of people that uses it on daily basis is 63%, so it's a large retention, and as well, most people spend at least 30 minutes on Instagram every day, which is incredible, the amount of retention that the app has. So you might wonder, what should I do to keep, to approach this? So one of the core principles for Instagram is simplicity. So not only on the UI, so you might notice that also the features tend to be like very minimal and thinking mostly against the, what's the minimal value that we can deliver to the user, the maximum value while doing the minimal thing. This helps a lot in terms of, not only the UI complexity, but also delivering faster and improved features to our users. So something that is also important for us is to have good coverage in terms of platforms. So an example, we have Instagram on the web, but also on iOS, on Android. And similarly, we also have it on low-end devices that most of them know that runs Android. So different surfaces, different experiences altogether. And this comes, I would say, as a cost from the engineering side because increases complexity in terms of like the different surfaces, and as well from the design perspective, you might think that it's a little more complicated how this is going to look on the web versus on mobile. So luckily, we have a lot of options from the engineering side. So in example, let's think about what we do on the web. So traditionally, you could use standard, web technologies like HTML5, CSS, and JavaScript. And then for mobile, on iOS, you would use, obviously, the tools that Apple provides. Similarly, on Android, you would use Android Studio and Kotlin nowadays. I think this is a pretty common setup for most companies. An alternative option that some websites would take is delivering also web components to the mobile people. I think this approach works for certain scale. Similarly, some experiences make sense to have offerings on web version, even if it's embedded in a web view. Some different approach that I would say is like most people follow is because when you use embedded webs or things like that, the experience kind of degrades, right? So it's not the same as using like a native app, which feels more performant and feels more close home in terms of design. So on Facebook, we use different technologies as well. So a very popular framework from Facebook is React, and that's what most web bits will be built on. And then over Facebook, they like this approach so much that they created a version for iOS. This one is using Objective-C++, which is a combination between Objective-C and C++. And they call it Component Kit. Very similar concepts that I'll expand on later on. Similarly, on Android, Facebook squished the most of the performance on the device by introducing a framework called Litho, which follows very similar approaches to both React and Component Kit. React as well introduced React Native, which enables people that are familiar with React and JavaScript to deliver like cross-platform experiences. Nowadays, Apple and Google kind of follow the similar component and React-based inspire heavily Swift UI and Jetpack Compose. So definitely consider using it if it makes sense for you. Over Facebook, some similar approach that kind of raised up, which is more into the topic that I'm covering, which is server-driven, was native templates. So native templates is a technology that was created within Facebook in such a way that they could deliver apps like Facebook Lite and a lot of surfaces on the Facebook Blue app. This enabled them to deliver both for iOS and Android, but the web would still use React and their version called Comet. So overall, this principle worked pretty well for Facebook, and Instagram followed suit by introducing an improved version of this that was more closer to the stack that Instagram uses, called blocks. So blocks enable Instagram feature engineers to deliver their features not only on the web, but also on Android and iOS. So the way this works is you can think of this as your browser, your regular web browser, in which you open a website and basically loads certain code and then renders it on the client. The fairly interesting bit here is that your browser ends up being more abstract in terms of what they know about the app, and at the same time ends up being very thin. So the approach is working towards those thin clients. In terms of what does that look like on mobile, so the way this works is like more often than not, when you're working on your features, you start by building the UI, right? So you think about, okay, how can I decompose this particular screen on navigation? What should be the sections? What should be, at the end of the day, everything, you can think of this as part of something, which we call components. So if we look under the hood, what you end up with is something like this. You have your frameworks, whether it's the Android framework or the iOS frameworks. And on top of this, you build some logic that could be a little bit also framework-ish, in which perhaps you use it for navigation or other certain things, which could be both business logic and presentation logic. On top of this, you build your UI with the tools that I mentioned before, which might include layout and some presentation logic as well. So you also use a server on most apps to be able to communicate the data back to your backend services. So very, very likely over there you also have frameworks called logic in there. And the way they interact mostly is through requests and sharing data. So our goal is to move all the UI and logic to the server in such a way that our mobile app ends up being more of a thin client, just like the browser that I mentioned before. You might wonder, why? What do we actually win by doing this? What we achieve is faster iteration. We also see some wins on productivity, and similarly on performance. So let's take a look at faster iteration. So you probably, on most of your companies, have a similar release cycle. I'm going to recap more or less how it works at Facebook. We try to ship a binary to the app stores on a weekly basis. So let's say that you are working on a new feature. You complete your features, you tested it, you incorporated everyone, you did a bug bash. Everything is looking amazing. So you're feeling like it's a good time to ship it. So what happens is that you merge your code on the main branch, and then on week 1, right? Monday, you sip your coffee, and then you hit the button, it's merged. And then a week goes by, and then you're able to finally see that code on the branch for production, right? So the way that we approach it is that on Sundays, an automated system cuts a new branch for the release in such way that we can build our production builds off it. So this one, we ship it to betas and so on in such way that it syncs on dogfooding, internal dogfooding, in such way that we get a lot of feedback about whether issues were introduced with it or not. And then finally, on the 3rd week, it's rolled out to the at a small percentage. In such way, by later in the week, we should have it at 100% in production. So you can see it's a very extensive process from the point in which you were able to merge your code to the point in which actually hits all of the users in production. This pales in comparison when we think about if we were approaching this from a server-driven release cycle, in which you land your code and then it's pretty much ready for production after a few stages on Canary and so on. So very easily you could merge your code and have it live right away. With regards to productivity, so obviously we chatted about this early on. So what this enables is multi-platform support in such a way that a single engineer using blocks would be able to deliver not only the UI and the feature on Android, on iOS, and of course on the web. So this is, like as an engineering manager, I couldn't dream of even something better, just one person being able to be this productive. This also enables an interesting scenario that might not be the case for most companies, but in our case, we have multiple apps. So creating a feature for all of them could be enabled by using blocks in all these different platforms. So in these different apps, what we do is we incorporate the blocks framework in such a way that we can, if we have a common feature that we want to ship across all the family of apps, we are able to do so, and the cost is minimal. Something that was very important for the blocks teams when they created this framework was for it to be very easy to learn and to test. So the way they approach it is by picking things from React in which you declare your UI in a very elegant fashion through code. It's very easy for you to learn how to compose your different principles. And as I mentioned, it's also composable, so very easy for you to test your individual pieces as well as your entire system overall. And another advantage of this is that the blocks teams think very truly about what languages to introduce. So most backend engineers at Instagram were familiar with Python, while most Facebook engineers were familiar with Hack, so they made it available across these different languages. Something that also comes, I would say, arguably on productivity ends, is that there is no need for designing an API, because at the end of the day, your navigation and then your UI ends up being the best API. So you don't have to think about designing your data objects, but more thinking from an UI perspective. Finally, I would say very happy that build times wouldn't be an issue, because what happens is that you use refresh, and then you have the latest versions of UI during development. Now, with regards to performance, we also have multiple wins in this dimension. So when you think about it, most popular apps trying to be as feature-rich as possible. So let's say for Instagram, we wanted to ship one feature A, And what ends up happening is this, increases the size of the app. Now, we want to introduce another feature, and this ends up being like costly. So it just grows out of control, and so on, until, like it's ginormous. So how can we tame this out? So by introducing pure server-driven features, we add zero size to the app. And we also, this would also mean wins in terms of performance in such way that we don't have to load as many classes. We also don't have to do a lot of context switching. And of course, this means wins for the users on perceived launch times and so on. Another thing that in terms of performance is super important is having that native look and feel, but also the performance of a native application, because at the end of the day, it's a native app. So I want to show you a few experiences that we built with blocks in such a way that very likely you have come across these different features, and you probably wouldn't have noticed that weren't like entirely built on the client. So when you compose a story, for example, you might want to add a sticker. So normally you would open the sticker picker, and then you would drag it around, and then you would have your sticker, in this example, the location sticker. So pretty common use case that I'm hoping that you experience it. So the sticker feature itself has been built with blocks, and the reason for this is that we have a large variety of different stickers that you are able to use. So for instance, the experience that you have on this quiz sticker is very different from another experiences that we have, like Ask Me Questions or like even music-related stickers. This also enables us to introduce new stickers along the way in such ways that are relevant to the things that are happening in the world. So, in example, for New Year's, Lunar New Year's, we can introduce a sticker that is targeted towards, like people that care about this topic and this cultural event. Similarly, we often incur in situations in which we want to share more information and enable people to make informed decisions, such as the case of the vaccine rollout, introducing an information center for COVID-related questions and common questions, and as well for people to be able to find vaccination sites. So normally this is surfaced through the feed, and then you access it, and the entire experience is built on blocks. Another use case of this was, just like with the COVID vaccine version, the US 2020 Election Registration Center was a very similar experience with a little more interactivity because people were able to see the elections at the progress within Instagram. Another use case that was launched by the live team was live shopping in such a way that as you watch, like someone try out their own products, you would be able to browse around and actually buy them right there while you watch, including with like the entire checkout process. I could sit here and speak maybe for hours about the different experiences that we have, such as two-factor authentication, all the security features that you find on settings. You can access them through it, and you wouldn't notice that they are not really in the client itself, but they are being downloaded and displayed to you. Another aspect of this particular framework is that it's embeddable in such a way that it doesn't take the entire screen, but in the case of stories, when you visit the viewers of your stories, this is also a component that was built with blocks. And when you think about it, like the shop experiences that you have on the app, the entire feature has been built on blocks. So lots of different surfaces, lots of different complexities have been implemented with this framework. As I mentioned before, in the case of Facebook, there are features that span across the family of apps. So this was very important, and an example, Facebook Pay has been built with blocks in such a way that can be delivered not only to Facebook, Instagram, but also other apps like WhatsApp. In this case, we're seeing the registration process for Facebook Pay within WhatsApp. This also incurs in terms of being able to deliver like a full-blown application of the size of 2 megabytes for low-end devices, and even for networks that have high latency. So you can see that the feature parity is pretty close to the actual Instagram app at a lower cost. So you can see we have multiple wins across the board. So I'll try to answer some questions that are quite common about this particular framework within Facebook. So a lot of people ask, is this a web view? Well, not really, because what ends up happening is that you implement this feature with native components. And in our case, we use a library called, which is open source. You can find it on Component Kit and Litho repos, which is called Render Core, which abstracts a lot of the rendering API for us. And we can squeeze the most performant out of the platform. So Blocks is built on top of this, not only using system or like frameworks that come from iOS and Android and the web, but also leveraging these abstractions. Render Core enables us as well to do a lot of view flattening, which means the view hierarchy ends up being smaller, being more performant. Similarly, we can do a lot of layout calculations on a background thread, on parallel, or even ahead of time. Finally, we can also do fine-grained recycling in such a way that not like the entire surface can be recycled, but also on the smaller items. And as I said before, this is also what powers Litho and Component Kit. So already open source, which is amazing. You might wonder as well, okay, we have a lot of cross-platform frameworks like React Native. Why not use that? So actually, Blocks use React on the web through Blocks.js. So we leverage this framework already for the web. But we don't really use React Native on Instagram for these particular purposes. But when you think about it, you could actually leverage these different frameworks to build, client infrastructure, if you will. So what I mentioned before, like perhaps navigation, and even like what I'm going to cover later about mapping, and as well building out your UI. And another I would say like something that is very key and differentiating is that React Native, renders these components on the client, which means that at the end of the day, your code is downloaded and lives on the client as opposed to of the backend. The React team launched something new around December time, which internally was called Flight, which is server components in such a way that rather than downloading the entire components to be rendered on the client, you can render some of them on the backend and save a lot in terms of the size of your bundle. You want to learn more about React server components, there's a link on the slide. Another question is, does this really support interactions or animations? They actually does. So you can get very swanky with it and just like create like very beautiful animations with it, very smooth native fill-in animations. So you can actually do all of this. Someone internally actually went and created a snack game with it, which I found it very funny and as a means to demonstrate of the capabilities of the framework. Now, another question that I get from people outside is like, will this be open sourced? Well, as of now, there are no plans within Instagram or Facebook to open source it, given that like the framework itself has been tailored by our use cases, so might not make sense for most people, but maybe we can create our own. Why not? So as I said before, when we think about our UI, so you can decompose it in multiple components. In such case, for this particular feed item, we could decompose it on the header, the actual body, and then, of course, the footer, which has actions on them. And as I said before, our ultimate goal is to move everything to the backend, right? Something very key here is how we use our data. So traditionally, what would this look like is that you design an API and you request just the data that you need to be able to fulfill that UI. So in the case of the feed item, we would ask for perhaps an ID, what type of media, whether it's an image or a video, like the actual URL to retrieve the actual media, the username for display purposes on the header, the timestamp, and so on and so on. So very tailored API for the needs that we have. So as I said before, by moving all of this, we actually change the way that we communicate with our backend in such a way that we don't need to design API, but rather our backend provides the structure of the UI. So how does that look like? So you can think about very likely how your view hierarchy is going to end up looking unless you flatten it. So on this example, we would use a container which will have children, and one of them would be a flexbox, which is a layout that we can use to express how to lay out the items, very similar to what you use on the web. This particular component will also have children, in which, in this case, we will have one of type text, which will render in this case, the username, and as well another one to display perhaps the avatar. Now, we were able to look at how the data will look like under the hood, but what does it look like, the actual pipeline? So on this case, we have example code from the markup that we use in Hack, in which uses something very similar to JSX. On Python, we have more of a code-driven declarative version, but at the end of the day, it's very similar experience. So as I said before, the UI is completely declaring in a very declarative fashion on the server side. So as I said, perhaps we can define a component class just very similar to what we end up sending on the wire, which has properties and both children. And then we can define different subcomponents that implement different properties or different behaviors for each one of them. But at the end of the day, most of these end up being just data containers for how we are going to express this on the wire. And then we can abstract some components like the screen. In this case, we could end up abstracting how we render it. And here's where we declare our UI in a very declarative fashion, very easy to understand and learn. Now, another step on the pipeline would be reducing it. So we can translate this to primitives that the framework will be familiar with, and even optimize it if we wanted to. Perhaps removing unnecessary containers that might not be used at runtime. We could do a lot of clever things here. So as I said before, like by doing a few passes of this, we could optimize the heck out of our response. In this case, I'm using JSON, but there is nothing that from preventing us from using a binary format in such a way that we end up with a more optimized data on the wire. After this, as I mentioned before, we actually have to transfer to the client. So the client has to perform some parsing and defining what components actually on the native side we are able to use it. So we build the model tree in memory, and after this we are able to, example, delegate to the client's frameworks in such a way that we can render it, very likely with native components. So for instance, for this particular item, as I mentioned before, we could use Python code to declare it. And then this particular Python code will be reduced to primitives by the framework that end up being represented in JSON for this example. And then finally consumed by the framework on the client in such a way that they are rendered using native views. Just as a concept, like this would maybe what the layout on Android will look like. Let's talk about data binding. So the whole example that I showcased before is what we would call server data binding, in which, given a backend data, what we do is we actually directly inject it on the component properties in such a way that end up being sent on the wire and also mapped in the model tree, and as well mapped into the native views. You might think that this works pretty well for most use cases, but as a matter of fact, might not work for all the use cases. So a good example of this is when content is not very simple. So we might end up with a large payload on the wire. Similarly, when the content is dynamic, this makes it a little more challenging to be able to programmatically mutate the actual view, and this incur as well costly benefits there. Another issue that we observe here is, let me try again. Clicker not responding. Another issue that we might find is that perhaps the content is not server-driven, it actually lives in the client. So that means that we cannot really insert content that is on the client or data that is in the client. So that creates another challenge that we won't be able to leverage this. What we can do is introduce client data binding. So this works in a similar fashion, but the difference is that we actually move out the data out of the layout, just like you would with your current approaches. But still, it's sent as a snapshot in the actual payload that we send to the client. And what we do is we create a binding between the property and the actual data, in such a way that when we parse it, we still keep the separation, but we have an unbound tree in which, like we would have, just example, the views without the content, and then we are able to merge any data or sync it by leveraging client logic, perhaps, or perhaps we can leverage the framework to do it for us. And finally, we're able to bind this data to these components and render it on the client. If we look closely how the binding operation works, as I said, perhaps on the server, we generate unique identifiers for a given data, and this is what we end up passing on the prop. And then what we do is we seek this item, we map it, and we're able to assign it to the bound tree. In such a way that further snapshots of the data, we can actually reference this and update the actual UI and content on the screen accordingly. This approach is very well known as an unidirectional model, in such a way that we don't end up with issues with concurrency or issues with data consistency. Another particular area that might be interesting to you is like interactivity and like logic that might make sense. So we can take a look at actions and scripting. So for actions, you can think about them like on client-side actions, such as navigation. So you could define an abstract way in terms of defining perhaps a way for you to navigate to an URL, or perhaps navigate to certain component ID, or navigate back and forth, maybe pop the screen, push another screen. Another client-side action that you might want to perform is mutating your props on the component itself, so such as changing the text. You might want to remove or add components on the flight, so this also ends up being a mutation. So finally, you can also do something around perhaps calling native frameworks to get, in example, your location or things like that. So this is called bridging, and the way it works is that you would call the method as you would normally do, but by referencing these actions. So as I said before, the way this would work is that like using the diagram is shown, you would define a prop, perhaps an example on tap, and then this maps to client-side actions, such as show alert. And then we can use props to define what's actually shown within the alert. And we can compose this on the client in such a way that it ends up being interactive when you tap it, and like the framework can automatically detect that there is going to be an on-tap action and add a click listener and trigger the code that is necessary to show this model. We can also perform server-side actions, such as syncing data. In example, you could be able to define a form and submit the contents of your different boxes through this particular form. So that's a particular use case. We can also use it to trigger logic on the backend. So all of these different actions can be actually predefined by yourself, allowing in mapping in on the client and making it in such a way that you have well-defined actions for you to handle, as opposed to arbitrary code for you to run on the client. Another aspect that you might be thinking, well, maybe I want some logic in the client. So the way that you can approach this is through scripting. So as I said, we want to prevent as much as possible from arbitrary code to be executed on the client. So we can use something as simple as expression trees, in which we can define a common set of operators that we really care about. And similarly, we want to incorporate how can we compose. So in this example, we are expressing a few operations that we want to break it down and their priority in such a way that we can traverse this tree from bottom left to the top and perform those operations. So in this example, what we would do is we would seek at the variable A and B and perform the operation plus, and then given in this priority, then we will multiply the result of that by C, and finally we'll sum it by 7. So this is how expression trees work. The beauty of this is that it's stateless. So it means that there is not mutability, just certain parameters come in, there is an output. So this also enables us to perform operations in such a way that they are one-offs, as opposed to be like, having concurrency issues. We wouldn't need really a runtime, just like a simple algorithm which solve this, which could be like pretty small. And we save the cost of a runtime and the security issues that might inquire. And as I said before, we have a well-defined set of operators and actions that we can actually perform in the client. That enables us to have better coverage by instrumenting our code and working on tests that just cover this limited set. And as well, this has the benefit of forcing most of our logic to live on the backend as opposed to being on the client. But okay, some people might be like inquiring, okay, no, I really, really want code on the client. I really want to push a code that I can evaluate and execute on the client. So the alternative is imperative programming. And the disadvantage of this is executing arbitrary code that you might want to verify before running. And of course, as I mentioned, you might require a runtime for that. So might as well look into an example, Hermes, which is JavaScript runtime, a small JavaScript runtime that we built at Facebook that is used by React Native. That being said, might as well just use React Native for that purpose.
Sir, I'm sorry, we just have 3 minutes left. I just had to warn you.
Okay, thank you.
Thank you.
I'll try to fly by on this. There is a lot of more topics that I would love to cover, like versioning. So most often than not, that we will end up is that sending repeated data to the client, like the layout itself. So this can be fixed by using versioning, similarly to the snapshot versioning that we could inquire. So this actually enables WhatsApp to deliver this by versioning like smaller payloads, and just like you would normally version your app, you can version your layout and version your data in such a way that we reduce the size on the wire. I mentioned the WhatsApp use case. So what they end up actually doing is bundling these payloads on the client in such a way that there is no communication with the server whatsoever. So you technically could just rendered your let's say your JSON payload and embedded it on the client, and the framework could interpret it at runtime, and then you don't have to incur like any need work. You could also do techniques like caching and prefetching. Bridging is what I mentioned before about calling internal framework and perhaps using different views that you normally would. We also don't touch much on collections recycling, so we could talk more about that offline if you want. Accessibility, very important. Animations, APIs, using design teams, style composition, and state, which is a major topic to cover. But given that we're short on time, I want to thank everyone for attending. I'll be taking questions offline. If you have any, please use the tool. Thank you very much.
Okay, so thank you so much. Unfortunately, we don't have an opportunity for some questions, but you can ask them online. If you will just like add our on air or online. I think that was awesome, seriously. Give a round of applause one more time, please. Yeah, so we have to go. Yes, thank you so much.